Okay, so we're going to create a new scene for now. So what we do is that we can actually delete the scene, or we can just remove everything in this scene for now. So let's delete, and everything is wiped out. So the first thing you want to do, right, is to actually, did I do the wrong thing? Okay, no. Is to actually do the same thing as before. Okay. Is do the same thing as we did before. So for the map, right, now we want to add a child node that is a kinematic body. But this time, what I want to teach you is how to organize your project better. Just now in the previous project, what your character was in, right, was actually a child of the map. You don't really want that, because what happens if you want to switch them? In that case, your map node, right, will now be changing to another node called map2. And it'll be stored somewhere else in your storage, in your project space. So in order to make the project run better, what we have to do is something called instancing. So what we do instead is actually create a new scene by clicking on this little plus button. And I didn't, wait, let me get my recording software so I can zoom in stuff and also write on stuff. Okay, so going back. So what I want to do, right, is actually press on this little button, this plus button, and we can create a new scene. This scene, right, you can actually do something, they'll always provide you a template like this, 2D scene, 3D scene. But it actually really doesn't matter, because what you can actually do is just press this plus button straight away, or you can press Ctrl A straight away, and you can add your own node. You know that this node is going to be a kinematic body, because you want this to be a player. So let's add a kinematic body. We'll have we'll rename this as a better name, call it player. Okay, with a player, right, one thing that we'll be complaining about is the collision, which means that this player does not have a shape. Let's give him a shape, but before that, let's give him what he looks like. If you have downloaded the asset pack that I provided in Discord and imported into your project folder, you will have it here already, as we've discussed from last week. So now we want an animated sprite, because what you notice is that in the asset pack that I gave, the player has a bunch of frames that he can use. So these frames will make up the animation of the player. So let's add an animated sprite. And can I hide the interface for finally? Okay. So let's hide the okay. So let's create a new sprite frame, which is this one. You have to click on it twice by creating a new sprite frame, and then click on it again. And now you can access the resource animation sprites. So now this resource, right, you can rename this animation. This stands for your first animation. You can add multiple animations. So you can add another one. You can call it walk. You can call it something else. For example, what you notice is that this person has many animations that he can have from this. We have a ledge grab with the run animation. So instead of calling this walk, I should call it run. And for the ideal animation, let's import all the frames. So we have frames 1 to 12. If you import it in and zoom in on the person, we'll be using the idle animation. And you click on this property called play, this person will start breathing. Okay? So this means that this animation sprite is going to be contained within this rectangle. So now we can give an accurate representation of the shape. Let's add another child node and have a collision shape. Okay, you will be used to this by now because we have added a lot of shapes before. So give this person a shape, give him a normal rectangle 2D, and make it such that this person expands outward. I'm holding the Alt modifier key so that this constrains to the center. All right, so this will be this person's animation. Will be this person's collision shape. Save this and save this as a player.tscn with Ctrl S. And now what we want to do, right, is we want to import this player into the map. Okay, so with this, you can add a child node, but what you notice is that your player isn't here. Because what you're trying to do is actually you're trying to add a node that is blank. But we have a node, and we have this player right here. So all we need to do, right, is to look at our project folder. Our player is right here. So all we need to do is add a instance, a child scene. Okay. And then we find out that all the scenes that you have made so far appear in this window. So all you need to do is select the player.tscn that you have made, which is your player scene. And you notice that there's this little button here called Open the Editor. This symbol means that this node is actually a custom-made node. In other words, it is composite. It has a bunch of other nodes that are not seen here. This player scene, right, is actually this guy. And when you import and instance this guy in this player into the map, you won't be able to see all its child nodes. This is the level of abstraction that is hidden away from you. Okay, because all you need to know is that this is the player and all its scenes, right, all its child nodes are contained within. Okay, if you click on this button, right, what you notice is that it brings you to the player scene. So this is referencing this scene, and this scene, this player, has all the children within it. Okay, so now you have the player within this map. And you can still control everything. You can change the shape of this. And the moment you press Ctrl S, right, this is updated. Okay. This means that this is reference and is up reference in what's it called? In real time. This will allow you to create very dynamically changing project. Now with our player, all we need to do is to attach the script that we had so far. Now just now I told you to delete everything. It's actually just deleting the children of that scene. But it actually didn't delete your functionality from before. So you can add a scene, and you notice that it will automatically come out of player.gd because player is the name. And it will load an existing script file. If you didn't have the script file in your project, right, it will say this will create a new script file. Okay, so what you notice is that when you load this, everything came back because it's still in your project folder. Unless it didn't come last week, then this will be empty for you. Okay, so what you have, right, is everything from last week. By the way, I changed my color scheme because it was very hard to see on the video. It's still very hard to see for the functions. Okay. So with all these movements that you have, right, what we didn't do last week was to program the WASD. We only programmed W. So just as a quick reminder, let's go back to project settings and we can change the keybinds over here. So go to the project settings, go to input map, and here you'll find your up was programmed as W. So your W was programmed as up last week. So what we forgot to do was to add a bunch of other keys for the rest of the directions. So for down, we want it to be S. So let's add a key, not a physical key. And we press S. And we press enter. And we press S and we press OK. Okay. For up, down, left, we want to put a key and we want it to be A. And we click OK. And for right, you want to click a key and put B. Now we have WASD. Okay. Now, our problem is that this button is flying off the screen and his friction is like very low. Okay, so this button is in zero gravity. So what we want to do, right, is we want to modify our movement. So let me pull up my previous, my actual ones. I have the player, I have the physics process here. Okay, so this is what I experimented with because I don't want to fumble in class. Okay, so I'll slowly bring in all the lines one by one. Okay, instead of doing this, right, seems very, brute force. You press up, then afterwards I'll make it move 2 units up. I press down, I'll make it to move 2 units down. That kind of stuff. That, right, can actually be simplified with this single line called input vector dot x get action strength. Okay, so let me type it out again, and let me put this down here and have a new variable called input velocity. Okay, don't forget that. Input velocity would be a vector.0. So input velocity is initial value. Okay, sorry, no. It's like that. Okay, yeah, so it's like this. Okay, I think it was, yeah. Remember this line is going to be clear. And it's back. Okay. Okay. Anyway, Zoom can ask any questions at any moment, just in case you're lost. So we have the variable input velocity. What this velocity is supposed to tell you, right, is actually just the variable. So if you get action strength, this line over here, what this does, right, is that it tries to map the vector x. Okay, so you have input velocity. Probably error a bunch of times. So you have an input velocity, and this is going to be a vector like this. Can be 0, 0 at start. Okay, we have the x component, and so this one is called input velocity dot underscore x. Input underscore velocity dot x, which is the x component of the velocity. Now we have something called input dot get action strength. What you had just now, right, was called input is action. Just press A or B, up, down, right, up, down, left, right. So instead, right, what you want to do is that when you get action strength, UI right minus UI left. Okay? So UI right, right, you press the S key, or the D key, it will try to move to the right, right? So this is called the input vector. Okay, so you are going to have a input action strength UI right. When you press to the right, right, you will have a value of 1. When you press to the left, you have a value of -1. When you press them together at the same time, it's 1 magnitude of -1. Okay, so the magnitude will be 1 as well in this direction. So it becomes 1 minus 1 becomes 0, which is expected behavior, because if you press both at the same time, you won't have anything. So if you actually press down, if you're creating a what's called top-down game, right? You press up and right at the same time, then the value that you should have, right, is towards the top right. And the value you have, right, should actually be third 2. Yeah, 2 third 2 instead of 1, because it cannot be signed off in the diagonal direction in the normal speed, which is not there. Okay, so what you want to do, right, is that you want to also if you're programming a top-down game, whereby you can move in all directions, right? You can have a up, get input action up and get input action down. Okay, in that case, it will be velocity underscore input velocity dot y is equals to input dot get action strength down minus input dot get action strength up, because up is the direction. Okay. So what we want to do next is to get this. Okay. So we have this so far. Now what we want to do is to normalize it. Okay. So if you want to create a top-down game, we're going to try to do a platformer game for now. If you want to do a platformer a top-down game, right? This is what you do. Okay. That's my control K. Okay. If you want to make a top-down game, this will be your input action getter. Okay. What is the complete input? That's not the current scope. Input vector, not velocity. Sorry, it's called vector input vector. Yeah. To get rid of that error. This was the mistake I was making. Okay, input vector. Oops. Okay. So I'm going to comment this out because we're currently making a platformer, which means that we don't care about top and down. You can press Ctrl K to comment out a line. Okay, so just for your note. So now we have a vector that is going to be either 1 or -1, 1 or -1 direction. So what we want to do is we want to normalize it. Okay, this doesn't really affect anything for now because we are not going to deal with diagonal vectors because it's only left and right. So what we can do, right, is that we can make the input vector always equals to 1. Normalization is something you learn in vector maths, whereby you have to take if it's like, for example, 2 and 4, then afterwards normalize the vector, you just get the magnitude. So it's going to be 1 over cert 2 squared plus 4 squared. And then you times it back into the vector. This will make it such that the vector magnitude will be equals to 1 unit. In that case, right, that means that when you go in the diagonal direction, then afterwards you always be 1 unit of 2 sub 2. So this is the way that we want to do it. So we want to normalize it. And okay, so currently we are at this point whereby we are going to normalize it. Now, right, what we're going to do is that we want to make the velocity be made into a different variable. Okay, so we can comment everything out from here for now. Okay, and then we can play the game. Remember, our move and slide is still there, so that means that we can still control the person. So you move the person, the person's not gonna move, huh? Did I forget to move and slide? No. I forgot to put the velocity. Okay, move and slide, normalize, slurp, vector 0, ready, action, input vector. Should work. Oh yeah. Oops. This will be velocity dot lerp, right? Okay. Now what we do, right, is that we want to get rid of this velocity dot x dot lerp for now. Change it into input vector. Okay. So now afterwards we play the game, play the scene, and it crashes because the x is not defined. So we put input vector dot x. Okay, you know what? Change input velocity equals to input vector for now. Okay, we're just gonna try this. Now we move and okay, hold on. Okay, let me get the lerp again. Okay, let me just copy this. Okay, we're going to have a constant movement speed. Okay, this will define the how fast the person is gonna move. Every single time you want to change how fast the person moving, just in case of like balancing purposes, then you can define a variable here. You can put it to 100 because you want. I think just now the person didn't move because it was too slow. And you also can put another constant called friction. Okay, your constant variables are always going to be named in all capitals. So you can put a friction to be 0.3. Okay, so now should work. Yeah, okay. Now you got a person moving. But you only can move left and right because you only define the input strength to be getting from UI right and UI left. Okay. Let me explain what this lerp is going to do. Alright. Can I zoom in? Yeah, I can zoom in. Okay. What you have here, right, is going to be you normalize the vector already. Then what you have is okay. Don't care about the arrow part first. Okay, so what you have right now is going to be the lerping. What is lerp? Lerp stands for linear interpolation. It means that it's just short for linear interpolation. There's a lot of ways to do linear interpolation in Godot that is something called linear underscore interpolate, and there's another function called I think it was like tweet. Yeah. So now you have a velocity dot x. What's the first argument that you're going to expect? The first argument that I'm expecting, right, is from, and the second variable that I'm expecting is the true variable. And the last one is going to be the weight. How fast or how slow are you going to interpolate something towards that value? Okay, so how linear interpolation works, right, is going to be, I think I should just draw on this screen. Yeah, I just draw. Because I have a pen anyway, right? Okay, so how linear interpolation works is that you have a value, and this is your initial value, for example. It starts from here, and now you want to move a value to 0, for example. So in order to do linear interpolation, what the program does, right, is that it tries to make the value move towards this value. Okay, it does it linearly. So if your time is like 5 seconds, you want it to move to 0 in 5 seconds, right? What the program is going to do is that it tries to interpolate it towards that value. So instead, right, what happens is that it does something like this. It tries to like half the value every time, and then you get like a third graph. Okay, so half. And then afterwards, eventually, right, of course, when you do a reciprocal function, you will never reach zero. But what the game engine is going to do is going to make it zero. So you can make it something linearly interpolate to zero, and then the game engine is going to make it eventually come to zero. Okay, so that's what is actually going to happen. You have someone moving, right? And then afterwards, you stop. You don't input anything. You don't put the keys into anything. So what the person is doing, right, is the person is moving at speed. I can't see my cursor, that's why I'm drawing so badly. Okay, so I'm moving at 5 centimeters per second. Not a reference to anything. Okay, you move at 5 centimeters per second. And then when you stop, that means that your input vector is going to be 0. In other words, you're telling the program stop. But instead of immediately halting the person, right? Instead of making the person's speed 0 centimeter per second, we want to add a bit of friction into it, make it a little bit smoother. It also helps in some gameplay whereby sliding can actually help make gameplay a bit more interesting. That's why in Mario, Luigi keeps sliding all the time, and that's what makes him a more interesting character. Okay, so if you make it to 0, right, what actually happens in the next frame is that it becomes 2.5 centimeter per second instead of 0. Okay, so if only I can. Okay, so that's how linear interpolation works. So now our velocity in this next frame, right, it was 100 units. So it will now be 50 units. Then the next frame will be 25 units. It will be 12.5. And that's what makes the person slide. Okay, and our move and slide, as we've said in the previous lesson, is to talk about how it's going to make the kinematic body move. The move and slide is a built-in function that really helps you to make things collide and move smoothly. Okay, so with that, that is our lesson about moving. Now you can make the person move in all 4 directions by enabling this line again. And if you play, the person can move freely in space if I manage to do it. Okay. So what you can do, right, instead is that you can loop both sides. So if you choose to do the y-axis as well, you can copy this and change it to .y. Okay, and now you play a scene. The y is going to loop as well. Now to make it the looping even more substantial, you can play around with the value of the friction. You can make it into 1, for example. Let's play a scene again. Wait, sorry, lower friction is better, sorry. 0.03. Okay, you play the scene. The person is going to take a long time to start up, and it's going to take a long time to decelerate to 0. You start again, and then he finally reaches full speed, and then he finally stops. That's that's very little friction. Okay, so I like to put the value 0.3 as a sweet spot. Okay, now let's talk about collisions. Okay, yeah, we'll do the instancing of items later. So what we want to do, right, is they want to go back to the map and we want to create a platform. Now, instead of creating one platform in the map, we also can create an instance of the platform. So why not let's just do that. Okay, let's create a platform. This is going to be a standard platform. In games, you won't really want to do this because the platforms will keep changing. It won't be a static object. But for all purposes, let's just go with a static body 2D as our new platform scene. Okay, if you haven't caught up yet, this is what we're going to do. Oops. Okay, this is what we're going to do. We're going to create a new scene over here, and then afterwards, we're going to create a platform. Okay, we create a platform, we add a shape. We add a new shape. We go to the 2D part over here to actually see what's going on. We expand this person out, and what we can do is that we can add some more look to the platform. Currently, this platform doesn't have any looks. So what we can do, right, we can give it a flat color, or we can give it a shape. Okay, so I'll show both of them to you. You can do a flat color, like what we did last time. We tried to make an arrow into a flat color. That one is called a texture rectangle. But what you want to do, sorry, it's called a fill rectangle. Okay, color rectangle, yeah. Instead, what we want to do is that we want to put a texture over it. Let's say you have a grass texture and all that. What you can do is that usually you want to do a tile map, but if you want to fill and wrap the shape with something, what you can do is called a texture rectangle. Okay, so it's control for drawing textures. Usually this is used for UI elements, but we can also use it for elements that deal with looks like that. Let's rearrange it, make it such that the scale, and you can press S to scale it down, scale it right over here, and scale it to the X, and this will be our texture. Yay. Okay, so now we add a new texture. And you look at this again, this is going to be a mess. Of course, there's way too many resources for us to choose from. So what we want to do instead is that we want to take a texture and we want to put it in. Now you can take a look at your art. There are a bunch of tile sets that we have not taught you yet, because the tile set is a little bit more complicated than that. So why not we just put the sprite and put it into the icon. Okay, so this is gonna be a stretch out Godot icon. What you're looking for, right, is this icon. This comes with every single Godot project, and it's kind of the most overused resource in the Godot community. Okay, so what we have, right, is that we have this. It's very stretched out. I think that's all right. And you can press the expand button to make it such that it fills right into the compounds or the bounds of the rectangle. Okay, so now you have filled it in, and this is going to look very weird, but this is your platform now. Okay, you can press Ctrl S and you can save it as platform. Okay, so with that, right, what we want to do is that we're going to go back to our map and we want to instance our platform. We want to put our platform into the scene. Okay, so let me go see if there is any questions. Prefab, I don't know what's prefab in Unity. Sorry, Gonza. Okay, so what we want to do is we want to instance a child scene. We want to instance that. Wait, let me put it back. Wait, did you say? Sheesh. Okay. So what we want to do, right, is I want to put a platform. So instance a platform, and now we have it here. You move it down and put it at the speed. You zoom out and you notice that your screen is way bigger than what the person is going to be. So you move it all the way down here. And what you can do, right, is you can actually scale it, make sure the platform is a bit bigger. So you can scale it up all the way like this. And there we go. You have your very large expanded platform. It looks damn ugly, but this is, yeah. Yeah. So you go to texture rectangle, or you can go to any of the platforms also can. You can see the visibility. There's a modulate over here. This changes the color. Yeah. So if you want to make it not there, you can actually make it to a black screen just by doing this. Or you can make it in. You can't change it to any other color, because what happens is that, yeah, it will just be overlaid over the icon. Okay, so black is the new texture, and you can Ctrl S and you can save it. Okay. So now if you play your normal map scene, right, you can press the big play button now. And what we'll teach you right now is to actually call the main scene. Okay, currently we don't have the main scene. The main scene is what essentially is the game, all the things behind it. So what we want to do now, right, is that we want to say that our map is our current main scene. Of course, if you develop your game further, then this scene will change. So let's select the current. Okay, if you're on the map, then you select the current. But for intents and purposes, let's create select. Okay, select, and then you find that your map scene, right, is where everything is going to come together. Okay, so you select your map scene for now. Okay, so now we can move. And when we collide with the platform, it won't change anything. Okay, so that's great. It's working. Our collisions are working. Now, one thing we can change, right, is the fact that we don't really want the y-axis later, but let's not do that now. Okay, so now let's create a ball. Because like what we wanted to discuss in Discord, this thing is a ball and it has two collision shapes. Okay, so next thing we want to do is create a ball. Okay, so we create a new scene. And we know what it wants to be. We know what I want it to be. I know it wants to be a kinematic body. So we Ctrl A and we write a kinematic body. Now, why is it that I didn't choose a rigid body like last time? Well, that's because rigid body, they have their own gravity and their own movements. That one is not going to be so useful to us right now because I want to define its movement. So if you want to define its own movement, then you should choose a kinematic body instead of a rigid body. So let's choose a kinetic body. It's going to complain like always, and it's going to ask for a shape. So give it a shape. It's routine right now. Give it a circular shape. Okay, so now you have a circular shape. It look like this. You can expand it a little bit bigger because we need some space for later on. Okay, so you can make it bigger. If you want to snap it to the grid, then you can open the two grids over here and make it into like 5 units. 3 units in radius. Okay, so now we have that. That is the normal shape. All right, so this shape is going to have a collision of, it is going to exist in layer 1 and it's going to interact with anything in mask 1. Now let's do some optimization. Currently, last week, I told you about collisions and masks. Collision shapes, about layers and masks. I told you that layers are everything that exists in the plane, whereas masks are everything that interacts with that plane of existence, wherever things that exist in there. So what we can do is that we can actually reduce some of the masks and layers here. Okay. So for example, I have in my map, this platform, right, is going to exist in the first layer and it's going to interact with everything in the first layer as well. What's the point of that? When I can just say that it's going to interact with everything in the first layer, whereas everything else is going to exist in the first layer and it won't interact with anything in the mask. Okay, so we go here. You can go to the platform. The platform now is going to be where's my here. My collision is going to be interacting, it's going to interact with everything in the first layer. My player is going to exist in the first layer, and my ball is going to exist in the first layer. Okay, so you see all the collision shapes. This is something that you should follow. Okay, so for a player, it should exist in layer 1. For the map, it should interact with everything in layer 1. In other words, it's mask 1. Expectation. Okay. So besides my running nose, I can play the game now and see that everything still works fine. Why? Because the platform is interacting with everything in layer 1, and my player exists in layer 1. That means that you just disabled some of the bit masks here, and you can save up some collision by trying to remove some of the collisions and not defining any of the collisions for some things that it doesn't need to be. Okay, so now let's add the ball that we just instance. Let's save this scene as ball. Okay, and I'm going to rename this kinematic body to ball, capital B, because it's a class. Okay, so Control S again. And what we can do is go back to the map and we add instance the child scene. So right click and you get instance the child scene, or you can Control Shift A. Instance the child scene, we're going to instance the ball. We're going to put the ball over here. Okay, now it doesn't have any gravity. Much like my player, I also don't have any gravity. If I want this to make it into a platforming game, I have to apply some gravity into my player and into the ball. Okay, so let's define some gravity for the ball first. Let's add a script to tell this ball to always go downwards. Okay, it's going to be called ball.gd, and we're going to create. So this is going to be a template. You can delete the template if you want to. And what it's going to have, right, is going to have the physics process just like last time. So every frame is going to call a physics process function. Okay, get rid of this. And what you have is the velocity. So much like you can refer back to your script, you found out that you have a velocity. So let's do the same thing. Let's have a velocity, a variable velocity that stores all of the, and you can dot 0. It's basically the same thing as saying vector to 0, 0. It's the same thing. Okay. If you want a shorthand for saying 0, 0, right, you can just dot 0. It's a constant. Okay, so now you have vector, the velocity being initially 0. Now, every frame, I want to make it such that it accelerates 9.81 meters per second downwards. Okay, so what we do is that we have velocity dot y. By saying dot y, you're trying to say that it's, that it's going downwards. And you plus equals 9.81, which makes it go down because positive is down. Okay, so now we have velocity dot y equals 9.81. Every frame is going to increase by 9.81. Now, with the magic of kinematic bodies, we call the move and slide function, and we pass in the velocity argument to tell it how much we want to move. Okay, so with this, what we should expect is that this ball in the map, okay, once everyone is done, in the map is going to fall. Okay, so I put it up here, it's gonna fall. Okay, let's play. And it does fall. Okay. Now, if I push it, it's not gonna affect me because I want this kinematic body, right, to be able to pass through me. Now, the player, exists in layer 1. The ball exists in layer 1. There's no interaction between these two because there is no mask to layer 1. Okay, so if I want the ball and the player to collide with one another, right, we would actually make this mask into 1. But I'm not going to do that now because I want to show that you want to collide with it and you want to interact with the center of it so that it flies upwards. Okay, so what we do, right, is that we want to create another collision shape. So in this GIF, I go to the center of this ball, and then this ball will now fly up. So that means that I want to interact with a certain part, this certain area that allows this ball to fly up. So what we want to do is that we define a hitbox, or we can call it a hurtbox. Okay, there's a difference between hitbox and hurtbox. Hitbox means that if you're attacking someone, if you fire an arrow, the arrow has a hitbox. It's supposed to attack, it's supposed to be punctuated. Whereas if you have a hurtbox, it means that anything will hurt me if it touches in this area, this vulnerability of mine. Okay, so what I want to do is that we want to instead create a area 2D. Okay, now you might be thinking, why not just create another collision shape? Well, what happens in Godot, right, is that this collision shape, right, is going to be tied with whatever is its parent. Okay, so if you want to create a hurt box and you want to create a collision shape that is also a child of the ball, right, it doesn't really make sense because now this ball has two collision shapes. It's going to take it like as if this ball has two physics collisions. But we don't want this shape to be a physics collision. We want it to be an area specified by us that is attacked by someone else. So instead, we define an area, and we call this area the hurt box, for example. Okay. So now we have a hurt box, and then this hurt box will then have the shape. Okay. So this hurt box will have the shape and will then interact with everything else, and then it will fly up. Okay. So it will complain again. Now we give it a circle, and we put it in the center. Okay, we just leave it. So this area will now be interacted by someone else, by the player. Now, if I have this collision shape, right, it means that I will have another mask, another collision mask. So what we should do instead, right, is that we should define another bit. So this thing, right, is going to be a victim. It's going to be a hurt box. So what we should, at least the mentality that I like to adopt, is that we should put it in a layer instead of putting it in the mask. Okay, so now we put this layer in layer 2. Now, if it becomes very confusing, what becomes layer 2, what becomes layer 3? Well, a good tip that you can have, right, is that just a little detour. You can go to the project settings. You can go to physics. Okay, it should be here. Search, go to physics. And then you have a bunch of these. You can name this one. Layer 1, I think we did this last week. We named it map. What we can do in layer 2 now, right, is that we can name it like the mob, for example. The area 2D that we created just now is going to exist as a victim. It's going to be receiving signals. And therefore, we should name this layer 2 as the mob. Or it is the ball. We can call it the ball. If you're making an RPG, it will become the mob. Okay, so now we close it. And this thing will now be in the ball layer. Okay, so it's going to exist in the ball layer. So now what we want to do, right, is that we want the player to have a hit box to interact with this hurt box. So what we do is that we go back to the player. Okay, we can control S the ball. We can go back to the player. Now, same thing. Instead of creating a shape directly as a child of the player, what we want to do is that we want to create an area 2D as a child of the player that has a shape. This area 2D, you can rename it. Now it's going to be called the hurt box. Okay, but it's a component that doesn't have a shape. Let's add a shape. It's going to be called a hurt box. I mean, you don't have to name this one. It's going to be a circle. Okay, so this circle, right, when it interacts with the other circle of the ball, it's going to make the ball do something. So what you notice is that, okay, so let's make this hurt box a collision of masking 2. Okay, remember just now we put it at layer 2. Now we put it at mask 2. Okay, so now the player should interact with the ball when his center part interacts with it. Okay, so one thing we want to show you is the signal. So let's introduce something called signals. If you go back to your 2D port, you go back to your inspector on the right side, you notice that there's another tab called node. Go to it, and these things, right, they're called signals. All of these are built in. They are built in by Godot. They're defined by Godot. So when something happens, right, these signals would run, and then you will run it in the Godot engine, and then should run the code. If you don't say anything, then it's okay. It won't run anything. But if you define something, right, then yes, it will run something. Okay, so all these are signals. The area has a signal, the ball has its own signal, every single node has its own signal. But each one of them differs by something. And what you notice is that the hurt box, right, has this signal called area entered. So this is what we are looking for. We want something to interact, to intersect with the other hurt box, the hit box. And then afterwards you want a piece of code to be run. So what we do is that we have to connect a signal. Signals must be connected. A signal is received and transmitted. So it's going to be transmitted here when the area is entered. Then it's going to be received by someone. And that someone is going to be the ball itself. Okay, we have a script here. That means that we have functionality. If we want the signal to do something, we want functionality to be where it is going to be run. So what you do, right, is that you double click, area entered, and then it's going to ask you, where do you want to connect this to? Where is your receiver? Okay, I want my receiver to be the ball itself. Okay, there are many other options that you can put. You can put it to another script, but currently we only have one script. In other words, we only have one of these symbols here. Okay, this script symbol means that it has functionality, and therefore we want to input it into the functionality. This line here, right, is going to define the function's name. Okay, so we click connect. You can click on advanced and you can find out there's actually more stuff that you can do, but we don't need to do that. So we just connect, and notice that it has created a new line. Just now we created the gravity. Now it has created a new line. So what does it mean? It means that we have a functionality that allows it to do something when it is collided. So on the hitbox area entered means that on my hitbox I have collided with something. I want my velocity y to move upward, to be launched upward. That's like the GIF shows. So if I want it to be launched upwards, right, what I can do is that I can plus equals -100 or like 1000 if I want to. Or if you also can put minus equals 100 or 1000. Okay, so now we're going to make this velocity go all the way upwards. And that means that when the move and slide runs again in the next frame, right, the velocity.y is going to be -1000, for example. And then now it's going to process that should move up 1000 units. Okay. So we go here and everything, we notice that the player should be all right. Okay. So when the player interacts with this area, it should run. So if I'm not wrong, functionality is here. Okay, no, never mind, nothing's happening. Okay, so let me go back to the player. Let me check hitbox, mask 2, hitbox layer 2. So on area entered, it should run. Okay, let me refer to my bold code. And minus 1000 area, move and slide. Okay. And my player physics process, move and slide. Everything should be okay. And my player is gonna have a signal towards the ball. Should be alright. Unless my hotbox is not running properly. Hitbox 2, ball is 2. Area 2. Area 1. Hitbox. Okay. Okay, I'm doing something wrong. Am I doing something? Yeah. Equals, right. I'm not supposed to pass. Supposed to be equals. Equals to negative 1000. That's right. Okay, yeah. Now it works. Okay, so you equals 1000 instead of pass equals negative 1000, because when you pass equals negative 1000, it only happens in one frame or something, I can't remember. Or it just doesn't happen. So you should instantaneously set it as negative 1000 instead. Yeah. Oh yeah. Right, yeah. Right. Okay. Yeah, should be the case. So if you want to, right, you can always print it out. Let me just print it out just to monitor what's going on. I can print out the velocity. Yeah, I haven't told them about delta yet. Okay, so now currently, right, the velocity is at 3000 plus. But it's currently increasing even though it's stationary. So what happens is that if I interact with it, right? Okay, never mind. It's gonna set to 1000, but what if I change it back to plus equals. Hi, whoever's watching the video, it's gonna be a short break. Basically, what I did was that I made the platform, the velocity. Where is it? Okay. Yeah, I made the ball have a velocity equals to move and slide. Okay, this is very important because it's going to make it such that the velocity will stop increasing after it collides. Okay, so that's it. Anyway, we go back to the player. Now we're gonna instance plus plus. We have arrow.cscn, we package it, and we're gonna instance it. Now we have arrow.position, and we're gonna set it to the same position. So what should happen is that when I press accept, I should have the arrow. But what you notice is that it doesn't happen. So that was my mistake last week. I press enter, there's nothing happening. What needs to happen, right, is that it needs this variable, right? It's not going to be in the scene anywhere. Okay, so we have this variable called arrow, but it's not anywhere to be found. You say it's a position there, but it doesn't know whose child it should be. So you need to say whose child it should be. All right, we're going to make this arrow be adopted by someone. Okay, so we say that the map is going to have a arrow baby. Okay, or you can say that it's my baby. Okay, my child. Okay, so what I can do, right, is I can do a very important function called add child. So add underscore child, it comes up already, and you can add a node. Okay, so the arrow, right, is this arrow variable is going to hold a node. You press add arrow, right, it's going to automatically be at your position. Okay, now you press play, right? You press enter. You notice that stuff is getting shut up. And you notice another unexpected behavior is that when I move, it moves. Okay, it's not expected behavior. Why is that so? That's because, right, when you add it as a child, its position is relative to yours. If I'm at 0, 0 and it's at 10, 0, and I move to 10, 0, its position will be 20, 0. Okay, so now it's going to be relative. How do we solve this problem? Well, we have to make it such that its position is not relative to ours. It's going to be relative to something that is static. It should be a child of the map. Okay, because the map is static. So what we do, right, instead is that we get parent. Get parent returns the parent node, which is the map. The map that I'm on is the map that the arrow should be on. I get the parent, then I get the child, and then I add the child. I get the parent means that I return the map, and I dot add child means that I'm going to add an arrow to the parent, which is the map. I'm going to add an arrow to the map. So with this, it's just the things that you need to get. So with this, right, what essentially happens, right, is that when you press play and you press spam enter, nothing, its position is not going to be relative to yours anymore. What actually happens, right, is it's something like this. Okay, so this is a very useful tip for y'all. When the game is running, what you can do is that you can click on this remote. What this remote means that where the game is running. Okay, the remote is where the game is running. So it has the scene tree. So much like what happened here, right, in your local, the scene tree is seen here. So your local is like this, right? What happens in the game is that it's going to have all the stuff back here. So the local was like this, right? Player, platform, ball. Here is going to be player, platform, ball. But now you have a bunch of arrows. And all these are instances of the arrow. Okay, so I spam like 10 arrows right there. And then now it's going to have 10 arrows as a child. What we did before, right, was that we had this arrow as a child of this player. And therefore, it will be following the player. Okay, so what does this mean? It means that when you're actually designing your game, right, some things should be a child of some other things. For example, if you're shooting a enemy, it has particle effects coming out of it, or it has like some lightning bolt that strikes it. The lightning bolt should follow the enemy. Else the lightning bolts, then after the player moves, the enemy moves, right? Then the lightning bolt is firing nothing. So what you should do, right, is that you should think about it carefully. What should be a child? What should follow the player? Or what should follow the enemy? And what should not, right? What should be a child of the map would be a child of a map when it stays there. Okay, so think about this is basically game design, the game structure. How you structure your game is how is very important, because when you put an arrow like this, it makes it such that it's going to, if the map moves, then the arrow moves, which kind of makes sense, right? Because if the world moves, then everything in it moves as well. Okay, so this is your structure. If you close the game, this remote closes and you won't be seeing it. So it's a very good way to debug. Is that when you play the game, you can go and find the remote and see what's going on in your game. Okay, it's going to be very helpful. So if I press the enter key, right, then now we're going to create some more. It's going to create a lot more. It's going to instance some more. It's going to instance some more. Okay, so that's how it is. Okay, now with these arrows in position, right, what we can do is that we can actually modify the behavior of these arrows. Currently, they're moving in the x direction of 1 and y direction of 1. What we can do is that we can add some player input into it, and let's try something fun whereby we get the, okay, it's turning very yellow because it's 9 o'clock. Hold on, let me get out where's my night light? Okay, hopefully the yellow stuff. Sorry, okay. So instead of making the position towards the like towards a certain fixed value, what we can do, right, is that we want to make it follow the mouse. In other words, we want it to congregate towards the mouse pointer. Okay, what we can do, right, is that we can actually get the mouse vector, because the mouse position is going to be a vector 2D. It's going to be a 2D vector. It's going to be a coordinate in space. So let me go back to my thing and find the arrow. I did not code the arrow because I forgot. Okay, so what you do, right, is that we position and we try to get mouse position, and we want to get the, when you say get mouse position, right, there's two. One is called a global mouse position, and another one is called the mouse position. The global mouse position is where the mouse is in the game, and it's absolute, which means that it's not relative to anything else. If you get the mouse position, right, it's going to be relative to the node or the map that's currently in. Okay, so to be safe, you rather use the global mouse position all the time. Okay, not local. the global. So you get underscore mouse global mouse position. Okay, what happens next, right, is that it's going to accelerate towards the value. It's not going to be good if you pass equals. And if you press equals, right, it's going to be even weirder. Okay, so let's just play. When you press equals, I have one arrow stuck to my cursor. And press another arrow, it's going to get more and more. Okay, so it's magnetized towards it. What we wanted it to do, right, is that we want to move towards the mouse cursor instead, for example. Okay, so instead of making it equals to, right, we can actually make it such that it moves toward. There's this really neat function called move toward. Okay, it's going to be colored red because it's like a keyword. What does move towards do? You can control click it. It's going to make a vector or a float move to from one point to another. I think it works on vectors too. Okay, so you can move from one value to another. Okay, it's gonna like make it move linearly, I think. So hopefully it's going to be correct. A few arguments. Okay. But move toward position is going to move towards from its own position to the mouse position. And it's going to move it by a fixed amount of 1, hopefully. Let's see. Move the argument called plus vector 2. Okay. Let's make it dot x for now and make it dot x for now. I'm just trying stuff out because I lost my edit, my previous code. So hopefully I'm getting it right first time. Okay. Argument 1. Pass argument type is, yeah, should be dot x. Okay, so let's see. Okay. Yep. Okay. So we have it. We have a bunch of stuff and it's following our mouse cursor. It's really moving really weirdly in the diagonal directions because we didn't actually set any of the like we only can set it as like a normalized vector in a way. But we set it as 1. Okay, once it's congregate together, then afterwards what happens is that it won't ever separate. Okay. So that's one way of doing it. You can look up the other ways to move the vector towards something else. I think it was linear interpolation as well, but I can't remember exactly which function I used to make it such that it's moving towards that thing. You remember? You have any suggestion? Move towards. So you use the move towards? Okay. Oh, move forward, right. Yeah. Okay, that's a way. I'm not sure if I'm able to do it now because I have to rotate towards and then is it rotate towards? Okay, let me try. Rotate. Rotation degrees. Okay, never mind. Forget it. For now, we'll just settle with this one. I will look up a better solution. Okay, so for now we've covered a lot. Any questions for now before we move on to talking about more signals? Anyone online want to ask anything? Okay, wait. Okay. Yeah. All right. Okay. So if you have no questions and this is really clear, then what we can do is that we can go fix our arrow first because it looks damn ugly. So for the color rectangle, right, it's a UI element. Usually we would advise against using UI elements because it's colored green, which means that it should be used for UI. But this is your game assets. So what you can do, right, is that you can actually, what you're supposed to do as a game developer is that you're supposed to add a sprite. Okay? And then you can get rid of this arrow, and this will be a sprite. Okay, as your sprite, right, what you can do is that you can import a bunch of icons into it. But we are kind of tired of using the Godot icon at this point of time because it's way too overused, and this is no way an arrow. Okay, what you can do is that you can actually you're supposed to open up your Paint software, or if you use Krita, okay, I'm not using Microsoft Paint, I don't like Microsoft Paint. So what you're supposed to do and advise as a game creator is to use a painting software like Krita or Paint.net. Krita is amazing. And then what you do is that you try to create a texture for yourself. Okay. Now what I did for my orbiter was to create a very shoddy looking I got a stylus right here, why am I not using it? A crappy looking arrow that is yellow in color. And then I imported this right into the game. Okay, so what I can do is that you can just quickly crop it. I'm gonna crop it, crop the selection, and I'm gonna save it. Now I'm gonna save it into my desktop. It's untitled.png because it's the best name. And then I'm going to, this is my arrow, okay, and I can name it as arrow.png. Now, every single asset that you have, right, you can actually go and put it into your game folder like this, like we did what I did last time, and you can just drag it in if you want to. It would be best if you organize your project to have put it into your art asset, because this is clearly art. Okay, you put it back into the art folder, and temporarily it's going to be here. Of course, this is a terribly organized mess. And what we do is that we drag and drop your icon into your folder. And we want to make the scale a little bit better. So if you want to go back to transforms, it's just a reminder that if you want to reset the transform to default, you can always click on this reset button. Okay, so that's my giant arrow, and I want to make the scale a bit smaller. So I select the endpoints and I hold alternate and shift at the same time to constrain proportions towards the center. Okay, and we have a arrow. Want to make it smaller because the hitbox is not working. Then we can make it into something like this. Okay. No, that's our arrow. Okay, so next is that we want the arrow to hit a ball, for example, an enemy. Now we already defined the ball to exist on layer 2. Same thing with touching the ball. We can have the arrow also do the same thing. So as a recap, we will have a collision shape that's already defined in the arrow, and we want this collision shape to be in the mask 2 and no layers. Okay, because we only want it to interact and affect other items. Okay, so we have the mask 2. Now, instead of actually making the ball a victim and running its own code of hurting itself, we can also do another way. Make it such that the victim is going to inflict the harm. Okay, so usually this isn't done because usually you want the receiver to deal its own damage, for example. So if you want to create a simple RPG, right, you want to do, right, is that you want to define a ball to have its own HP, for example. Okay. Currently what we can do, right, is that because we don't have any what's it called? We don't have any looks of this thing, we can add a sprite. Okay, and we're gonna use the most overused. Yeah, this is my sprite. Yeah, show here. Okay. Use the most overused icon in game development, and that's the Godot icon. Yay. And you can hit this poor thing until it dies. So what happens is that you move it to the top so you can see your collision shape, and you make this guy smaller. I Control Shift and I screwed up. Okay, there we go. And it should go up, yeah, like this. Okay, so when you hit it, then afterwards this HP gonna go down. To define the HP, right, you have to say a variable. Let's create a variable called health. And we will set this to 100 at the start. Whenever the hitbox is entered, it should take damage. So HP minus equals 10, for example. Okay. Now HP minus, okay, sorry, not HP, health. Health minus equals 10. When health reaches 0, this thing will die. Okay, make it die, right? You have to do something called Q free. What's free? Okay, let me just tell you. Okay, so health minus equals 10. Every single time it takes damage, right, then we will try to check if it's dead yet. Okay, so let's see if health equals 0 colon, then it will auto indent for you. Die. Okay, so you can call a die function. All right. Let's just create a new function because this is good programming practices, and we create a new function called die. Okay. this function die would Q3 this item. What is Q3? Q3, right, is actually just a variant of the function free. There's some guy called free. Okay, what free does, right, is that it instantly causes this node that this script is in. So this script, right, this .gd file, .ball.gd file is attached to this ball, which means that when I call this free, right, it's gonna free ball. Okay, when I free ball means that I'm gonna make it disappear from memory. It's gonna be gone from the game. Okay, so what's Q3? Q3 just makes it such that it waits until the processor is available for you to free it. Because if you instantly free it, right, sometimes there's this problem whereby something else is needed by it. Because you know that games can run concurrently at the same time, or like two things can run at the same time. One thing needs another thing, and when this thing is gone, and this thing cannot find the other thing, then the game crashes. So to prevent this from happening, right, Q3 makes it such that it's a safer way to remove items from the game. Okay, so your game will not face many crashes with this Q3. Of course, there are some things that are still there is still your responsibility to monitor, which is like how some things will not have a parent anymore when you Q3 it. Okay, so some things can be found in the game when you Q3, and of course, removing stuff from the memory will cause a lot of errors in your game. So make sure that when you're debugging your game, this Q3 is something that will be something of the most concern. Okay, so Q3 would make this thing disappear. Let's check it out. Okay, we're gonna every single time we minus the health, right, we're gonna print the guy's health. Okay, so we print health. That's to check. Okay, we can even remove this velocity here because it's jamming out our outputs. Okay, so let's remove this velocity so you don't ever get to see that in the output. Okay, so you press a game. Then you move towards the guy. He took 10 damage. And he flew all the way upwards because he was so scared. And he took another 10 damage. Then he's gonna take another 10 damage. And this is taking way too long, but you get the idea. He's gonna die eventually. So now he's at 60 health. He is gonna go with 50 health and 40, I'm still counting, 30 seconds. 30, 20, and 10. And when he reaches 0, what you should expect is that this guy dies. Gone. Okay, so Q3 makes it such that this guy is no longer exists anymore. So if you go to the remote, right, he's dead, confirmed it, because he's not even here. Doesn't exist anymore. So that means that yeah, that's how you remove stuff in the game. To add stuff into the game, you learn that you add the child. So there's this thing called add child. So add child gives birth. Q3 kill stuff. Okay, so that's your two tools of adding and removing things in the game. And also, you've learned that today that when you get the parent, it is also very important to know what is his parent, what is his child. Okay, so for some rearranging purposes, let's move this downward. Okay. No question? Okay, no question. So, can get rid of all this because this was the old stuff. And this as well. Okay. So that's all our code for the player and the ball and the arrow. Okay, what we can do is that we can also make the arrow attack the guy. So all we need to do is it's already defined for us, right? Oops, undo close that. Okay, so it's already defined for us. The arrow is going to have a mask of 2, whereas the ball is going to have a layer of per box of layer of 1. So it's already implemented into the function. If you play the game again, now instead of colliding into it, right, what we do is that the arrows, and I think when it moves towards it, it's going to fly upward. So yeah, it dies instantly, I think, because I sent 10 arrows at it, I think. Yeah, it died instantly. Okay, so you get some game ideas from this. So instead of like colliding with a person and making the person fly up and taking a long time, you can actually create a game out of this by you summon a bunch of arrows, like 10 of them, and immediately ask them to ambush the guy and kill him instantly. For example. Okay, that's just like one game idea that you can have. You know, the different choices the player has. So instead of that, you can also make your projectiles have a different functionalities. So if I'm correct, our lesson today is only supposed to cover Q3. Let me think. We have this custom function called die. Yeah, we have this custom function called die. What we can do, right, is that every single time we have this function in any of the objects, any of the scripts that we have, right? Yeah, if you do object-oriented programming, they are called public functions, which means that they can be accessed by any other function. So that's the benefit of doing this. So we have this function, right? What we can do is that when this arrow collides with this instead, it's gonna cause the same functionality. But what if we don't want the arrow to make the guy jump up all the way? Okay, we only want it to attack when we go towards it, right? We want it to make the ball launch up. But if the arrow touches it, we don't want the ball to launch up. Okay, so what we do, right, is that we set an if statement for this velocity dot y launching up. If this area, okay, is equals to let me see. If this area is dot name, okay, I can do dot name, yeah, dot name equals to the player, then we will launch it upwards, and then we'll run everything else. Okay, else if anything else, then afterwards it's gonna run everything. Okay, so what this means, right, is that this area, where does this area come from? Notice that it's highlighting this argument. This argument, right, was not set by me. It was set by Godot. In all the predefined functions here, right, what you notice is that they have this little parameter here. See the things in brackets? Those are parameters that will be passed to your what's it called? Passed to your signal function, the method. Okay, so this is called a method, by the way. Notice that there's this little button here. This means that this is a signal method. It's a receiver member method. Okay, this will be run whenever a signal is called, and it'll be passing an argument automatically. You don't have to define this argument. So whenever something enters this area, right, this area argument will be filled up by Godot. Okay, it will tell you which area entered. So that's really handy because this area would be useful in telling us what hit us. If what hit us has a name called player, then I will fly all the way upwards. If it wasn't, I won't fly upwards. Okay? So you can do this dot name. Okay, so what does dot name means? It's just simply a property that of a node. Okay, your name, right, is basically stored here. You name it something else, it won't work. Okay, so let me show it to you. If I play the game, I shoot an arrow and fire it, it will take damage. As you can see here, it took it took 10 damage. If I move towards it, it will take damage and it didn't fly off. This is because I'm named wrongly. I think it's because I'm named wrongly, huh? Hold on. Let me go back. Player in. Oh yeah. Sorry. Okay. I did something wrong. It's not supposed to be player. Because the area that entered me, right, was not the player. It was the hitbox. Okay, hitbox, sorry. Is it hitbox? Yeah, no, it's called hitbox. Yeah, it's called, but I named it hitbox. I should name it hitbox. Sorry. Okay, it's called hitbox. The area that entered the ball was not the player. Because the player's shape, right, was actually the bigger one. The thing that actually entered it was the hitbox. In the hitbox area, the hitbox name is called hitbox, not player. Okay, so what is actually supposed to be here, right, is actually called hitbox. Okay, now we have an arrow here, and this arrow, right, is collision shape. The arrow's name is called arrow because the arrow's collision shape has no physics, so we don't actually need a hitbox for it because it's redundant. Okay, so we have a hit player, and now when we play it, we go and shoot an arrow. It's going to take damage. When I go towards it, it's going to fly up. That means that the if statement actually worked. Now, if you want to monitor what actually went through it, right, you can actually print something because it's very useful to print something. Okay, because I'll go to the ball, and to debug what actually happened is that every single time the hitbox area is entered, you print the area. Okay, and you print the area dot name. Okay, just tell you what name it was. So whatever I said just now, right, about the player entering it, right, it's actually the name of the area that enters it is not the player, it's called the hitbox. And when I shoot an arrow, the name of this arrow is called arrow. Okay. Now, last thing I wanted to go through was to talk about passing methods and functions from one area to another. So if I am the player who is going through it, I want it to move a velocity of -1000 upwards. But what I can also do is actually make the area dot velocity equals to 100. In other words, I'm going to launch it to the right. What does this line mean? This line, right, area dot velocity equals 100. This area is going to refer to this parameter here, which means that it's going to be higher than positive. This area, right, is of hitbox. I'm going to set this area to the velocity of 100. Something as well. Yeah, can you tell me what this area dot velocity?
It doesn't really know if it has a velocity.
So back then what it is that when I dot velocity, right, it actually pops up. It means that it detects that it has a velocity. Where is it? Area dot velocity. Yeah, it's there. What is actually wrong, right? It's actually the fact that this area is actually not separated. This area is the headbox. Because the name is so I should actually get that. Let me show you that this doesn't work. And hopefully I'm right. If I touch this guy, it's gonna fly upwards because my name is called dot hitbox. And it crashes because I don't have velocity. Yeah, it pops up, but it's actually wrong. I don't have the velocity. Why? Because I'm actually referring to the hitbox. This hitbox doesn't have velocity. Only the player has a velocity. So what I should do is that I should dot get parent. Okay, so dot get. Let me get separate and parent. Now it doesn't pop up, and then we get the dot velocity. So what happens is that this guy is going to be passed this hitbox. I'm going to call it get its mummy, and its mummy is dot player, and the player is going to have a velocity, and then I make it 100. Okay, now it should be velocity dot x actually. Yeah, because it's a single variable. I play it, and now it should work. I hope. Okay, I'm not launching. It's because I did not touch. I'm gonna wait here just in case it actually launches me. Am I moving? Yeah, I think I'm moving. Yeah, I move a bit. I should exaggerate the value. 1000. Okay, so I move. I launch a bit. So if it just hits me again, I'm gonna launch to the right. Yeah. And it doesn't hit me. Then I launch to the right. Okay. So this means that velocity dot x. Now just now the crash that happened is actually could be because I didn't learn dot x. So let me test it again. Yeah, it crashes. Okay, it crashes because it doesn't have velocity. Okay. Yeah, so you should actually just get parent first. But this means that the lesson from learn about this is that you should actually, whenever you get a crash, you should inspect and remember what the area is supposed to represent. Which one is it representing? This area, right, is actually just referring to this area dot hitbox. It's not referring to the kinetic body. Okay. Which one? Uh-huh. Yeah, you can also do that. But so I don't know why Godot actually recommended me the dot velocity. Yeah, maybe weird. Like it auto completes dot you know the law area dot Okay, it's not coming up. Okay, area dot. Okay, I don't know what's wrong. No, it popped up there. You saw it. I'm not crazy. I see it's here. Even though it doesn't have it. Okay, yeah. So sometimes Godot can a bit. Yeah, you gotta check it on your own time. So if you got the parent, get this daddy, then you got that is velocity because only daddy has this velocity. Okay, so that's your velocity, and that's it. So, any questions about inheritance? Parents have velocity. The child doesn't have velocity. That's why you cannot. Any questions online as well? Brian, thanks for joining us. It's my NS friend. Okay, we're locked in. Yeah, don't worry, there's a card there. Someone generously donated their card. Okay. Mhm. Yeah, so it's like a scene tree. You mean the get parent one? Yeah, it's a scene tree. So it's referring to a scene tree. So if I press play, I get the remote. Okay, I go to remote. It's gonna have a player. This hitbox, right, is what's interacting with the ball's hurtbox, not the player. So when I dot get parent, right, I'm getting this. And then I'm gonna get the velocity because it's within the script. So within the script, right, you can actually go to the debugger, and then I honestly don't really know how to use this, but there's a bunch of stack frames and stuff. Yeah, so what you can do is that when you collide with it, question. Yeah, I mean this is quite simple. The once you know this, you can actually do a lot of things. Like it's a very powerful tool because now I can just call any function of anything that is public. Okay, if you want something to be private, I think it's a private. There's a private keyword here. Okay, no, there's no private. Okay, I'm gonna do private, but it's okay. Yeah. So that's it. I don't really know why it crashed. Should be alright. Let me try again. Okay, I forgot what happened. I think it's because the ball screwed up with the velocity. Dot get parent velocity. Oh yeah, it's because the dot x. Oops. Okay. So that should work, and that's it for this lesson. Yep. Anything else you want to know, you can ask me privately, or you can ask in the Discord group because there was no interaction on the Discord group, which I was quite sad about. Maybe I should, give your homework or something like what I my senior did. Yeah. Yeah, we didn't even do it, honestly. Well, I can give you a challenge and think about what to do. So what you can do, right, is you can what do you want to do? I'm thinking platformer stuff. Oh yeah, you can implement a jump feature. Yeah, you can implement a jump feature. Okay. So here are some hints. To do a jump feature, right, what you want to do is first of all, disable this line because you don't want it to move in the y direction. Now, if I go play the game, right? Oops, I can't move now. Wait, hold on. I'm going to get a velocity. To make it a real what's it called? Platforming game, right? You have to force the velocity downwards. So dot y is going to plus equals 9.81 every single frame. Okay. What else, right, is that you should also set the move and slide velocity to equals to itself. Okay, this would reset the velocity whenever it's colliding with something. And lastly, this one will actually give you gravity. Okay. Now I'm slowly falling, which shouldn't make sense because the lerping is still here. So let's get rid of this. Press Ctrl K or I can delete the entire line. Now, when I go down, press the play, I fall. Okay. And also, when I press spacebar, it also does that. But yeah, but now I cannot jump. To implement a jump function, right, a tip that for you all to have, right, is that you can have an input vector or a velocity that whenever your input dot action is action press, is action just press, okay, yes. Is action, okay, yeah, is action just press. And you want to say UI underscore jump or spacebar, but you don't have a spacebar. So to get you started, right, what you want to do is that you want to go to project settings, input map, and you want to implement a spacebar command. To do that, you press A, you add a new action. At the top of here, right, you will actually find this bar that tells you that you can add a new action. So to join the ranks of UI accept, UI select, all that stuff, you can actually just write here, player underscore jump. Okay. Then you add this, and this adds up at the bottom. So what you can do is you can add a physical key. A normal key, you press spacebar, and this will be your player jump. Now you go back here, and you player, it appears there. Okay, so you press that, player jump, and then you have a condition, and you make something there. So that's the challenge I want you to try, is to make the player jump. Now, I haven't told you, but if your approach, right, is to make the velocity go up, right, you're on the right path. But one thing that you can try to avoid is that it flies all the way up. Press space bar, and then the guy is gonna fly all the way up. So in games, right, like Maple Story or any other performer, you can only jump from. How do you do that? You can Google, you can find an answer because I Googled before, someone provided me an answer. That's very nice. Okay, so how do you jump when you're on the ground? You can do something in move and slide. There's a little hint. Move and slide, right? That's the second argument you can have, and it's going to be very useful. Okay, it's called this second argument that you can pass. It's not passing me. Okay, okay, I'm gonna pass here because this is the homework. Okay, so if you're gonna what's it called? Move and slide, right? Okay, okay, okay. Move and slide. The second is called up direction. Okay, that's gonna be very useful for you to define what's the ground. The ground is when you're on your ground, your normal vector is upwards. That's what is defined as the ground. Okay, so that's the end of this lesson. Thank you to everyone here and people online. If you have any questions, you can ask me right now. Also can. Yep. Else you're all dismissed. And yeah, we will have another lesson next week as per normal. And we will be talking about, I forgot what's my plan. Welcome tea. Okay, so remember at week 5 we will have a game jam. Okay, so this was my welcome tea slides. Yeah. In week 5, oh wait, sorry. The 1 week game jam is when? One day, right? 24-hour game jam. Yeah, the 12-hour game jam 10 September, which is next Saturday. So we will have one more sessions here on the 8th. And then we will start to do a very short game jam. Okay. 12-hour game jam. Okay, you have all that. We will also provide you additional assets. Okay.
It's the same asset in here. Meaning that we will provide all the assets to use. Then you just focus on using anything that I never provide everything. We never provide music. So if you want to, if you got spare time to get your own music, you can. Yeah, but I think the point you record the okay, so the thing about the 10 September game jam is that you can participate solo or you can team up with friends, okay? All of us are all like Godot people, right? Most likely will team up with each other. So if you guys want to form your own teams, then you can start thinking about it before 10 September. And the event itself is face to face because we are gonna give out free pizza. Yeah. Normally, you food panda pizza to you.
Yeah. Okay, besides that, right, we also noticed that after week 5, right, we'll be teaching about animation trees. Hopefully I don't have animations. Okay, but besides that, right, after that will be more freestyle kind of thing. I will be monitoring, I'll be providing advice on how you. So in that case, right, we'll have to form teams. So form teams and run their in competition. We will try to be one big and after this you will whatever game you want to be able to. The next week we'll be covering groups, game structure, critical turns, object, shadings. Okay. So be excited for that. And we also do comments, which is something that the Unity because currently our background is like crap. Background. So in order to make the background nicer, we have to implement tilesets. Okay. And parallax backgrounds also. Okay. So that's it. Yeah. Thank you. Mm. And thank you to everyone online as well. Yeah.
Maybe we can make a page on next week and whatever code we do.
Oh, the GitHub.
Yeah.
Okay, I can do a GitHub. Yeah, I also package it with dots because currently our
Yeah.
so I think it would be better if I got it because I'm going to scrap the entire project afterwards. Yeah. Okay. Yeah.